All right, so today is a second lesson on circles. Make sure you finish the homework, okay? And you're given about 13 or 15 problems each time. What we're going to study today, another important theorem on the circles. Okay, we already talked about tangent line to the circles, right? So today's theorem is if you have a circle, and this is the center, okay, C, and this is an arbitrary point, P, okay? So now you draw two lines, you fix A and B. Yeah, C is the center. So you got two angles. So those two angles, one is called alpha and the other one called beta. The theorem says that alpha is going to be double the angle beta. Okay? So I'm not going to spend time to prove it, but this tells you if you move the point, if you fix point A and B, and then move the point P on the graph, on the circle, you are not going to change this angle beta. It's still same angle as long as A and B are fixed. Yeah, it is surprise, right? You know, suppose when you move the point P around the circle, you are going to change the beta, right? The angle beta, but actually the beta angle does not change. Okay. This is an important case. The special case is what happens if when AB are on the diameter. Okay. If AB on the diameter, this is a C. Okay. And here alpha is going to be 180 degrees, right? Then you pick up arbitrary point P. You draw the line, and this should be beta should be equal to 90 degrees because beta is going to be half of alpha. So beta must be equal to 90 degrees. So this, as long as if it's a triangle is inscribed in the circle, and the other side is one side is on the diameter, then this triangle must be right triangle. Okay? This information usually is not given directly, so be careful. Okay? You have to use that property to solve a geometry problem. Okay. So let's try let's do some problems. This is the important properties, right? Recall that we have another important property we already mentioned in the last class is if we have a tangent line, right? So this is a tangent point, right? And then the center connect. This also must be 90 degrees. Sometimes you use that to form a right triangle. Okay. All right. So we call this important property. So now we're going to look at the following problem. Suppose you have two circles and they intersect. One is larger, other one is small. Two intersecting circles have the common chord. Okay, so this is a 24 centimeters. Okay, we also know that the radius of the smaller circle is going to be 13 cm. The radius of the larger circle will be 37 centimeters. I want to find the distance between the two centers. So to solve this problem, I already draw two radius, right? And sometimes it's not given. The picture already helped you to draw. So to solve problems like that, step one, if you already did some homework, you should be able to get some idea quickly, right? You draw the lines. You have to draw connect the important points. So connect the two centers. Then once you connect the two centers, you immediately see a right triangle, right? You immediately see a right triangle. So the question is, how do you use those properties? You get two right triangles, right? You get two right triangles. Okay. So we're going to find this, right? So this is a perpendicular. It's a right angle, right? You have two right triangles. One is this. Another one is on the right-hand side. There's also two right triangles. Then how to find the distance between those two ones? Just use just a sum of those two pieces, right? This piece and that piece. Just add them together. And this side is 12, right? Divided by 24, divided by 12. So 12 centimeters. So the distance is going to be, the first one you apply the Pythagorean theory, it will be 13 square minus 12 square. And the other one will be 37 square minus 12 square, right? And you compute it, then this will be 5. The other one is that there's a famous theorem, a special right triangle, 12 and 35 and 37. So this will be 35. So the answer is 40, okay? Yeah, when you see 37, when you see 12, if you memorize a few special right triangles with integer lengths, then you should know this side will be 35, okay? Because this is a special right triangle. My next problem will be, here's a larger circle, and this on the diameter. I have two circles. One is larger, other one is smaller. Okay. So the smaller circle, here's the larger circle. The ratio is going to be 2 to 3. Okay. So we're going to find so we're going to find out the unshaded circles are tangent to each other here, and their centers are on the diameter, okay? So what is the area of the shaded region? We have to get the radius of the largest circle is R, and I needed to get additional information. Yeah, find the ratio. Find the ratio of the area of the shaded region and the area of the largest odd circle, okay? Largest circle. Because I did not tell you the size of the largest circle. The largest circle, right? The largest circle outside. So what means, what proportion, what fraction of the circle, largest circle is shaded? Okay, so you just take the okay. So this is the center of the circle. It's not in the middle, right? It's on the diameter, right? So the radius of this largest circle, I believe that it's going to be capital R plus little r. You know why? Just look at the diameter. Diameter is 2 capital R plus 2 little r. Divided by 2 will be r plus r. Okay. So this is going to be the area shared regions pi capital R plus little r square minus the area of the medium-sized circle minus the area of the smaller circle, and divide by the area of the larger circle, right? So we want trying to simplify this. Got it? So I probably don't need to do any, just do some algebra computations. So pi will be gone, right? So you get r plus little r square minus capital R square minus little r square. Right. Let's continue. I can multiply this out, right? It's r square plus 2 capital R little r plus little r square, and yeah. So this capital R canceled out, this little r canceled out. Okay. Then all you need to do is just divide both numerator and denominator by r squared. So you will get 2 little r with capital R here, and here's 1 plus 2 little r with capital R, and here little r with capital R over capital R squared. Okay. Then you know that each of them is going to be 2 over 3. So it'll be 2 over 3, 1 plus times 2, 2 over 3 plus 2 over 3 squared. Then you simplify. Okay. And again, if you simplify, you still multiply by 3 squared. Back. 3 squared, 3 squared. And so you will get 12. Here, 3 squared is 9. And this will be 12. And here will be 4. Okay. Okay, so the answer will be 25 here, and the top one 12. It's 12 or 25. Okay, this is a so now we're going to use the theorem to solve the following problem. Suppose we have a circle, and this is a center O. O is a center, right? And that's a beta. That's a theta. All right, let's see what do we have here. We are given the following information. The radius R is going to be 9 centimeters, and that'll be 20 degrees. Yeah, beta is going to be 20 degrees, okay? We want to find out, what do we have to find out? We have to find out the area of the sector enclosed by OR. Okay, find the area of this sector. of the set MO. Okay. Let's this is notation. Okay, so just to share the region. Okay, first of all, what they have to do is write down the formula, right? So area is going to be half of theta r squared. Okay, and theta is in radians. So the next step, what do we have here? So this is almost a straightforward problem. It's a two-step problem. So you're not given the theta directly, but you're given beta. So theta, you have to, is this in radians, right? So theta is going to be double the beta, is going to be 40 degrees. But 40 degrees is in the degree measure. So you have to convert it to, radians measure. So 180 degree is equivalent to pi. So this should be divided by 180 degree times pi, right? Then you simplify it, you get, you can simplify it, right? So step by step, if you can divide by, both 18 divided by 4, right? Okay. So it's 2 over 9, okay? It's pi. It's easy to see that. Get rid of 0 and 4 over 18 is 2 over 9, okay? So that's in radians. Then the area is 1/2, 9 over 2 pi, and r squared is going to be 9 squared. Then you cancel it out, 2 cancel out, it's going to be 9 pi. Okay, it's square centimeters if it's, okay. Okay, so the next problem I wanted to work on, we have right isosceles triangle, right? This is right isosceles triangle. So I already gave you 45 degree, 45 degrees. This must be right isosceles triangle, A and the B, and this and the B and the C. Okay, what I'm going to do is a circle is joined. A circle is joined, passing through B. Okay. Find the area of the region inside the circle but outside the triangle. Okay. Find the area of the region inside the circle but outside the triangle. Okay, so this is a region inside the circle, right? But outside the triangle. It's only 2 pieces like that. Okay, so please try to work out this. Again, remember geometry problem, you have to connect the important points first. Then you probably get some idea. So just go ahead and connect the important points. What are the important points? Intersection points, right? Tangent points, centers of the circle, right? Those are space. You should use a pencil, it's draw it. Then maybe you got some ideas after you look at the picture again. So we did not give you too much information. Sometimes even the original picture is not given. Just use a language to describe it. Right? So those are the important points, right? And this is also important, and this is the important points, right? So those are the important points. connect them, right? How do you connect them? Connect them, connect them, connect them. Oh, great. So those are all the lines, right? Then you see and the B and the D definitely is a diameter, right? If B and the D know it's diameter, right? So you will see lots of special this is the center, and this must be 45 degree, right? 45 degree, and this must be 45 degree, 45 degree. So all those, so what you get is you get a square. Of course, it does not look like a square. I did not draw it correct. It's a square, right? So question is, how do you find the area of the shared region? Only one piece. You multiply by 2, you get a total area. So you just needed to look at this piece, okay? That piece. How do you do that? Oliver, do you have answer? Brian, do you have answer? So don't talk. Sophia?
So if you don't have like the links and anything, so I just use X. So.
Oh, you did not have a links. Yeah, you can assume.
I just assumed that it's X, and then I got 3 pi X squared divided by 64.
So yeah, you don't need a. I'm going to give you some information. Okay, let's assume that AC equals 24. Okay, units. Yeah, sometimes you give, this, yeah, we have to give some information about the site. Otherwise, your name is just called A, right? Number one, well, step one, figure out the radius. The radius. Okay. The radius is going to be the height of this isosceles triangle divided by 2. Okay, divided by 2. I'm going to see who is online and going to check it. Okay, so I'm going to call your names. Okay, Alex, do you have answers? Are you working on the problem? So the first thing we have to do here is to find the radius, right? The radius is going to be the half of the height. So you have to figure out the height, right? So this, as AC is going to be 24. So, so this will be 12. And this 45 degree, that's 45 degree. So that must be 12. 12 divided by 2, 6. Very quick. You can get 6. Okay, that's my first hint, right? Once you get radius, how do you get that shadow, area of that shadow? Okay, you just need to focus on this part. Okay, you don't need to know. Yeah, you don't need to know part of this. Okay? Can you can you find the area of this region? Right? Not yet. Yeah, you multiply by 2, you get a total, right? Yeah.
Just the region over there.
Yeah, just this small region, yeah.
36. Oh, 36 pi over 4 minus 8.
Okay, so let's see. So this angle, so this is the area of this region, right? You're going to the difference, the area of the sect. How do you find the area of the sect? Half of the theta times r squared. Theta is pi over 2, 90 degree, right? R squared, 6 squared. You have to minus the area of the triangle. Area of triangle, half of 6 times 6. That's it. Okay. So so that will be 9 minus 9 pi minus 18. If you multiply by 2, you get the area of these two pieces total. Just take the difference. Yeah. Remember the formula for a sect, if it's a theta, right? For the area. Area is going to be half of theta times r squared. Right? So just use subtraction. You cannot find the area directly. But with this technique, we always use a subtraction. Okay? Using subtraction, then you can solve the problem. Okay? Another another similar problem is you have a square. Okay? Square, that's called 6, 6. Okay? So you at the end, each end point, you draw a circle, and then with radius 6. Then you also draw another circle. Okay? So you got 2 circles. So you get a picture like this here. Okay, circle. Yeah, circle. Let me finish the circle. This is a circle. That's too large. I cannot draw here. Right. So this is also circle. Okay. So what is the area of that region? Yeah, find the area of shaded region. Okay. Yeah, you have a square clear, right? And 2 vertices, and you draw the 2 circles, you get a common part. Right? This is yeah, how do you find the area of that part? I'll need to give you a hint, right? If you know how to do the previous problem, you can do this one. Samuel So, you say it's nice. I don't know. Anyone give me? Edward, I just see you. Can how you work on the problem? Rule number one, remember, right? Draw the lines if necessary. You know, connect important points. There are only two lines you can draw, right? But maybe the other one is not unnecessary, like this one, the diagonal, right? And another one is like this, right? Those are two lines you can draw. But once you draw this, you immediately can see the see, that's what I already did it, right? Why? Because you divide this region into two parts. And then remember, we already did this, come on, right? Right? That portion, that's two pieces of that portion, add them together. Okay? All I have to do is just find what is the area of that part. We already did it, right? So the area of that part is here. Can you see that? Right? So that's it. See, the area of the sector, right? And minus, this is 6, 6. So the area of the sect minus the area of the triangle, right? It's going to be 9 pi minus 18, okay? 9 pi minus 18. So here, this is just double it. The area is going to be twice of 9 pi minus 18, okay? That's it. You don't need it to do anything. Just cut it, and then you see that. Okay. Another way to do this problem is, you don't need it. This is the best way to get. So you just cut it, and then you look at, you use a subtraction to find the areas of one one piece. Then you solve the problem. Okay. Right, so our next problem is going to be a circle, and then randomly I draw two lines. Okay, just random. Okay, and this is going to be A, C, and B, and D, and this is the intersection point P. Okay. We are given the following information. Three sides are given, just trying to figure out the other side. Okay, I know that AP is going to be, let's assume AP is going to be 4, and BP is going to be 3. Okay, and the PD is going to be 5. Find the PC. Okay, this part. So I already know here's a 4 and the 3 and the 5. Then you will say 2. Why? By guessing. It's not exactly like that. Yeah, we have to use the two facts. We have to use the one we already showed to you. You know, suppose, this is a alpha, this is a beta, this is a alpha. Okay, it's a fixed. Beta equals half of alpha. Yeah, we probably need that. And then no matter where you choose the angle, right? This is always beta because alpha is fixed. Okay. How do we solve this problem? We draw the, remember rule number 1, right? Connect the important points. I probably have to connect the center, but I probably don't need a center here. I just use this line and this line, okay? Right? Maybe another point is the center. You know, you can try, but this time the sentence is not very useful. Okay, then what? So this side I call the X. Okay. I find the two similar triangles. Okay, let's mark it. Okay, this is alpha, that will be alpha, right? That point to each other. But A and the D are fixed. So if this is a beta, that angle must be beta. Okay, and if the B and the C fixed, so this is gamma. This must be gamma. So you get two triangles. So corresponding angles are equal. So, so those two triangles are similar. Okay, so let's write down the corresponding side. The triangle APC is similar to the triangle A corresponds to D. P is P, and then B. Okay, C corresponds to B. Okay, so that means the ratio of the corresponding side must be equal. So X to 3 should be equal to 4 to 5. Yeah, so X is going to be 12 over 5, not an integer, not 2. Yeah, we find the two similar triangles. This is a nice example. Okay. Yeah, even three sides, three pieces are integers, but the third one is not. Okay, our next problem. A triangle is inscribed in a circle with radius 13. Okay, so the radius is going to be 13. Right. This is on the diameter. Okay, one side of the triangle is on the diameter. Okay, if the perimeter of the triangle is going to be 60. Okay, my question is, what is the area? What is the area of the triangle? Of course, the circle is already known. There's no need to draw the addition lines. The only addition line I can draw is this, but I find out it's not necessary. I cannot use that condition. Okay. Unless I want to find the area of each piece. Okay, then I need to draw the line. You know, if this is A and B and the C. Sometimes I ask you, hey, what is the triangle? This is O, right? The center. What is the area of triangle AOBC? Okay. Then you have to then you have to draw this line AO. Okay, between A and O. Right now, I'm just asking you to find the area of the triangle. Okay, how to find the area of the triangle? Can you find A and the C and and B. Okay, that's the first question, right? Second question, can you find the AC? Because BC is already known. So if you find the AC, then you can find the BC. Okay. We assume that AC is shorter than BC, otherwise it goes the other side, right? Yeah. We assume that AC is shorter than AB, okay? The short one. BC is clear. BC is 26, okay? You know that, right? BC is it's on the diagonal. Okay, that's two questions here. Maybe you can answer the question direct the same time. Oh, Edward gave me answer already. 120.
Yeah, 120.
Kellen got 120. Can you find the AC? The second question. Yeah. All right. So let's name it X and the Y, right? So first of all, let's give a condition X plus Y plus 26 is supposed to be 60. That's the first condition. There's any other conditions we'll give? It is a right triangle. Okay, important. It's a right triangle. So you have to write down the equation for the right triangle. It's going to be 26 squared. Right? So from here, you have to find out the area, which is half of X times Y, right? But if you can find the X, you can find the Y, then it depends on which one you want to find the first, okay? Yeah, find the product and X. So let's find the product, right? Look at this equation. Okay, X plus Y is going to be 34. Okay, X squared plus Y squared is going to be 26 squared. I think we can quickly find X times Y. Okay, X times Y is going to be, because X plus Y, this is important identity. Do you remember this? Okay, this is an important identity. And using that, you solve the problem. So you get 34 squared, and X squared plus Y squared, 26 squared, and plus 2XY. So you don't need to find the X and Y directly. You can still, then you simplify, right? So area equals quarter, X times Y, right? And that's with 34 squared minus 26 squared divided by 4. Okay. So what is the best way to simplify this number? I think the best way to simplify, don't multiply this, don't square it. You use this form this way to simplify. Okay. So 34 minus 26 is going to be 8. 34 plus 26 will be 60. Then you can see that equals 120. 120 is the area. Well, if we get X times Y, right? What is the best way to get X? You can use a quadratic formula, right? If you want, that's direct. Yeah, X times Y is going to be 240. You can have, X plus Y equals 34. X times Y is going to be 240. You can from here you can solve for x. Okay. So let's solve for x, and y is going to be 34 minus x equals 240. So you get a quadratic formula. Okay. So you got negative x squared. So I'm going to put x squared. Okay. So this is a direct way to solve the problem. So you can solve. You get two solutions. You just choose a smaller number. Okay. Yeah. So 34 plus minus b squared, 34 squared minus 4ac. Okay. And since you have to choose a smaller number, so your answer will be minus, not plus. Okay. Well, it's a larger number, right? So just simplify, you get an answer. Okay. I'm not going to waste time to do this. Okay. So you just simplify. That's not the best way probably to do. The best way I want to show you is x plus y equals 34, and x times y equals 240. So what I'm going to do is I'm trying to get x minus y squared, okay, which is going to be x squared plus y squared minus 2xy. So already know x plus y squared, right? X squared plus it's 26 squared. 26 squared. And also have a 2 x times y. X times 240. Now you get 480. I don't think it's better. Anyway, so x is smaller. Okay, so you get x minus y is going to be plus minus. You take the negatives. Okay, then you add them together, you get x. You probably get the same result. Yes, you will get the same result. Okay, add them together. It's 2x equals 34 minus 26 squared, 480, and divide by 2, you get the answer. That's another way to do without using quadratic equation. But still end up with similar to the quadratic equation expression. All right, so let's stop here and go to the next problem. This time I still have a circle, and I have a diameter E and C. Okay. So yeah, this is a C. So I'm going to have a rectangle. A and B and C, that's O. So it's on the diameter. Okay, that's a D. Okay, here's a picture. Yeah, EC is the diameter. Okay. When I know that EC equals 5, AE equals 3. Okay. O is the center of the circle. Find the area of the rectangle. Okay, find the area of this rectangle. This is a rectangle. To find the area, see, EC is already known, right? But you still don't know the length of the width. No, it's not as a square, it's a rectangle. Yeah, so you have 5, that's a 3, right? But when you see 5 to 3, the addition line will be this. You have to connect the important points, right? So what you get is get a right triangle. Now you can you find the area? The geometry we're studying here is quite different from what I studied when I was in middle school, high school, because that time we have a lot of problems that have to prove something equal. Here we just do the computation. That's the difference. Okay, but you still have to claim something. Hey, these two are equal. You know, those two angles are equal, in order to do the computation. Okay, but that much less proofs here. 3 over 12. 3 over 2. Any different answers? Yeah, let me check. Charleston. You need to find the age. And let's call this part is X. That's called Y, right? You just find H times Y. So this is a right triangle, and the AC is clearly it's going to be 4. Right? Should know this is right triangle. So basically you get, I think you find the H first, quickly. Got it? That's my hint. You can find the H quicker. First of all, you recognize that this is this triangle AEC is a right triangle. Okay? And the AC is going to be 4 because that's going to be 5 squared minus 3 squared. Okay? That's my hint. Redo the problem. I want to get Edward. Good job. I'm going to cover the answers. Okay, please do the problem. We have answers already. Yeah. Kevin. Michelle, Ding. Hmm? 2 times square root 12. No, it's not that. X, Y, H are all fractions, no radicals. Yeah, we did this similar problems before, I remember. Just focus on, say, the circle is used only for the purpose to prove ACE is a right triangle. Okay? Now you just need to focus on this right triangle. Okay, A, E, C, and H, right? And here's X. This is the Y, right? And this is 3, here's a 4. X plus Y equals 5, right? And how to find H? Find the H, X, and Y. Just basically find H and Y. If you can get H, you can get Y, you can get Y, you can get H, right? So it depends which one you want to try first. There are many ways to find the H and Y, okay? Use the similarity of triangles, even you can get it very quick. Okay, use the area of the right triangle, you can get H. The best way to do, quick way to do, is to use a similarity of triangle, not a Pythagorean theory. Okay? All right, so the best way you can get it, this is alpha, right? So I'm going to write down another triangle. This is a beta, okay? And this will be alpha, this will be beta. Okay? Alpha plus beta is 90 degrees. Okay, so let's find the corresponding triangles. Yeah, there are 3. Okay, here's A, here's E, this is a C. Okay, because this is alpha, that's a beta. Let's put it this way, right? No, this is alpha, that's beta. Okay, and then another one, a little bit smaller. Okay, and this is going to be alpha, so that will be A. And this is point D, okay? A and D and C. C is still beta, okay? And then much smaller one is on the left, okay? This is alpha, or should be E. And that's a D, that's A. All right, so then let's write down what do we have here. We have a 5. AC, that's a 4, and a 3, okay? And the other one is AD is X, AC is a 4, DC, no, confused. Okay, DC is Y, okay? AD is H, okay? Then DE is X, that's be 3, that's H, okay? So you have 3 triangles. You write down all the possible identities. You compare those two, 4 over Y. Okay, write down Y first, variables first, okay? Okay, Y over 4 should be equal to 4 over 5, should be equal to H over 3. That's only one, these 2 triangles already gave you all the information. You don't need as a third smaller one. Okay? That's the best way. Okay. So Y is good. Is going to be 16 over 5, and H is going to be 12 over 5. Okay. So area is going to be H times Y. 16 times 12, 5 times 5, it's 192.25. Yeah, use a similarity triangle is the best quick way to do, but otherwise it's a little bit more complicated. If you find the H, you have to use a Pythagorean theory to find the Y. Okay, how do you find the H? How do you find the H? If this 3, here's 4, this 5, how do you find the H? You find the H using the area of the triangle, okay? Using the area of the triangle, which is going to be half of 3 times 4, and this is supposed to be half of 5 times H, so H is going to be 12 over 5, okay? So use that, you can get a Y, use the Pythagorean theory. But that's not the best way. Use the Pythagorean theory, you have to use the radicals, you have square, all right? And I think it's better to use a similarity triangle scale. Okay. Similarity triangles. Okay, let's try next one. I have a two congruent unit circles. Maybe make it easy. I just use a radius 2. Okay, make it just a little bit computing easier. Two congruent circles of radius I equals 2. Okay, intersect each other in the following way. Okay, as follows. One circle passing through the center of another circle. Okay, so this is the center. So you see, you have an intersection path, right? This time, it's different from the one I was talking about, right? So different from the one, you know, the square inside square. So I want to find the area of this intersection path. Okay. To solve this problem, you have to, oh, that's too big. Okay. Yep. Yeah, it's harder to draw two identical circles. Yeah, I think it's important to take some drawing classes, drawing circles. Straight lines. The first step is you put 2 points on a piece of paper. Without the ruler, can you draw a straight line from one point to another point? That's the important skill. And then you put a 1 point and draw the circle around that. Okay? You can practice that first before you draw anything else. All right, so important points. Remember, I told you, connect the important points. This is the important point. This is important. Connect them. What you get is a triangle. What is that triangle? Can you see that? Kelly? So is that special triangle or not? You know, you connect those important points. You can also connect to the points here. It doesn't matter. It's identical. Right? So what do you get? This is how special this triangle. Because this is a center, right? This triangle, all the 3 sides are going to be the radius of the circle. Do you agree? Because the radius, right? So it's 2 and 2 is 2. It is an isosceles triangle. All right? My hint, if you understand the previous example I discussed, my hint is if you can find out the area of this shaded region. If you're able to find the area of this shaded region, you can solve the problem. Why? Because you know how to calculate the area of the equilateral triangle, right? Equilateral triangle, the area is going to be, right? You remember the formula, right? Equilateral triangle. If it's 2, it's 2, it's 2. The area is going to be square root of 3/4 times 2 square. So just square 3. So area of the equilateral triangle you can calculate, and if you know how to calculate that small area, then double the area of the equilateral triangles, and the more and the 4 times the area of the small pieces. Then you get the total area of the intersection. So how do you find the area of that small piece? I'll give you 1 minute to think about. Karen, work on that. Don't talk. No matter where you sit, you're always talking to the student next to you. Did you solve the problem first? You haven't, right? And you already, if review remember what we did at the very beginning, right? Similar, right? We did some problems. Find the area of a small piece, okay? See, Edward gave me answer here already, huh? Just find the area that's small, yeah. Find the area of the shaded region, okay? This shaded region. Okay. So 8 of 3 pi minus 8 square root of 3. That's what Edward says. I don't know the answer yet. Just say, you just find this small one, right? If you're able to find this small piece, the area of the small piece, you can solve the problem. Okay? Oh, what did you say? Divide by 4. So this is an equilateral triangle, and the angle will be pi over 6, pi over 3. Pi over 3, okay? And the radius is 2. Okay? Got it? That's my hint. Come on. The equilateral triangle, the angle is pi over 3. 60 degrees is pi over 3. No, you got it. How do you find the area of this shaded region? Well, basically, you just need to find the area of this sector minus the area of this triangle, right? That's it. Right? So the area is going to be the sector is half of pi over 3 times the radius square minus the area of the equilateral triangle is square 3 over 4 times 2 square. Right? That's 2, 2, 2. It's 2, 2. And pi over 3. Okay? So you will get 2 pi over 3 minus square root of 3. Okay? Yeah. You got it? Yeah. So if you find that, then in order to find the area of this this piece, right? then you can see that the area of this shared region, the area of the intersection, right, is going to be how many pieces? 4 pieces of that, right? 4 times 2 pi over 3 minus square root of 3, and then plus twice of the area of this 2 equatorial triangle. You can do like this, okay? Then add them together, you solve the problem, okay? So you get 8 pi over 3 minus 4 times square root of 3, okay? And plus, this is a 2 square root of 3, okay? So the answer will be with this. Okay, this is probably the more direct way to solve it, but you have to recognize, you have to use a subtraction to solve the problem. So if you have a sect in general, let me summarize, right? This is a radius R, right? How to find the area of this shared region? Clear, right? So the area of the shaded region is going to be the difference. Come on, just different. Half of theta times R squared. Right? Now, the problem is if in general, it's harder to find the area of the triangle. So you have to find another way to find the area of the triangle. Right? If I already know the other side, let's call it A, then you can find the area of the triangle. Can you find the area of the triangle for this in terms of I and A? Right? Of course, the theta also determines the size of A. I'm not going to, because you have to study that in the high school, called the cosine law, okay? If you have a R and theta, you can determine A. But usually, you are given A, then you find, theta and A can be determined from each other, okay? But I just gave you the A. Can you find the area of the A? Well, find the area, this is the isosceles triangle, so it will be half of the height times A, right? Height, base is A, but the height you have to calculate using the Pythagorean theory, R squared minus half of A squared, for example. Yeah. So that's the formula, right? If you have a isosceles triangle, how to find the area, right? So you use a Pythagorean theory to find the height. Then you calculate the area. So anyway, just ideas takes the difference of the two areas, gives the area of the region. Use a subtraction to find it. Okay, so